So that was a lot of deep dive stuff on slices, and you won't need all of that all the time, but as I mentioned, you should have at least heard about it. Now, slices are not just a useful feature because you can make other people dizzy by diving into slices on slices and stuff like that, but also because with slices you can create dynamic arrays. Because let's come back to that original prices array. One downside of using that array was that we had to define ahead of time how many values we'll have in there. Now, sometimes in the applications you're going to write, you know exactly how many values you'll have in a list of values. For example, if you handle some user input in a form that has exactly 3 form fields, you might have an easy time storing those 3 values in an array because you know ahead of time that you'll get 3 values. But let's say you're loading a list of prices from a database, and the data in that database changes frequently. Then when you write your code, you don't know ahead of time whether you'll need 4 or 5 or 100 prices. So having to set the length of an array in advance in your code can be a restriction that's quite annoying. In other programming languages like JavaScript, you don't have that restriction. There you can create an array and it's automatically dynamic. So you can always add and remove elements just as you want to. For Go arrays, that's not the case. Prices is an array with 4 elements, and you can't just add a 5th element, even if you wanted to do that. Now, since we have that restriction, Go thankfully also has a solution for us, and that solution again is that slices feature. Now I'll comment out this main function because I want to keep it here for reference, but I don't want to execute it anymore. Instead, I'll write a brand new main function so that we have an empty, cleaned up main function to dive into that slices for dynamic arrays feature. Let's say we again have some prices, but this time it should be a dynamic array where we can add more values whenever we need to. You can create such a dynamic slice with a syntax that's similar to what we saw before, so square bracket float 64 curly braces, but you may now also omit the length here. If you don't specify the number of items that should be stored in this array between those square brackets, Go will actually automatically create a slice for you, and since a slice always is based on an array, it will also create an array for you behind the scenes, but it will automatically ditch that array and create a new array if your slice grows beyond the bounds of that behind the scenes stored array. But we'll see that in a second. So here we can create an empty slice like this, or maybe even populate it with some starting values. Both is possible. Now we can still work with that as before. We can build slices based on this slice. We can select individual elements. So for example here, I can print prices 1. And if we run that code, unsurprisingly, hopefully, we see 8.99. Now we can also select a slice here if we want to, like this. And if we execute that, we see 10.99. So that's still possible. That all works. Now we can, of course, also assign values like this to override the second value. But what we can't do is assign values to indexes that are not part of the slice. If we would try to do that and we then output prices thereafter, it crashes because the index is out of range. I don't get this error in the IDE, but I get it when I try to execute that code. So we still can't access indexes that don't exist. But I told you that this would be dynamic, right? But not like this. Instead, there now is a built-in function in Go, the append function, which you can execute like that, which, as you see here in the tooltip, wants a slice as a first value and then a list of elements that should be added to that slice. So here we could refer to prices, which is a slice as I mentioned. This syntax creates a slice, and Go creates the array that belongs to the slice behind the scenes. And now we can, for example, add 599. And that will now append a new item, but it will actually also return a brand new slice. So it actually does not edit the original slice, but instead what append does is it tells Go that we want to add an item to that slice, and therefore also to the underlying array. Now, of course, an array has a fixed length. So what Go will do in this case is it will create a brand new array and add that element to that brand new array, which is created such that it has the capacity for that new array. So here I got my updated prices, and I can now print my updated prices here if I want to. With that, if we now run this program, we see that we got our updated prices here, which is the original prices slice and therefore array plus the 599. Now, if I would print prices here as well as updated prices, so if I print the original slice and this new slice, you see that the original slice did not change. This is still just these two values, just 9.99 instead of 8.99 because we overwrite this here. But the original slice in array was not changed by Go. If you wanted to do that, you would have to instead reassign this appended slice to the existing prices slice instead of creating a new variable. Then, of course, if you do this and you output this prices slice, then you'll see that it changed. And again, Go will manage the arrays for you behind the scenes. And if you reassign an appended slice to an existing slice, it will of course also ditch that original array, which only had 2 elements before, and use that brand new array that holds that extra 3rd element for that slice instead. So memory management is taken care of by Go here. And since we now have that extra flexibility where we can always add new elements if we need to, it's way more common to work with slices right from the start in Go than it is to use arrays. You can still use fixed length arrays if you know for sure that you will never have more than X amounts of elements in a list. But if there is at least a slight chance that you might want to add new elements as your program executes, you should definitely go for this slices approach right from the start instead. Because that allows you to add elements to slices and to let your arrays grow just as they need to. Now, in case you're wondering whether there also is a function to remove elements from a slice, since there is an append function, well, yes, kind of. We can of course just create a new slice that removes the element we want to remove. If we want to remove the first element, we simply create a new slice based on the existing slice that starts at the second element and selects everything up to the end. That gives us a brand new slice that omits that first element. So with that, we of course did remove that first element, which was 1099. So that works like this. There is no function for doing that since we already have the built-in mechanism with that feature that allows us to build slices, this slicing syntax here. Working with arrays and slices is actually not that difficult, but we did learn a bunch of very important concepts over the last minutes. And hence it's time to practice what we learned. Attached you find this practice.go file, which contains a pretty empty, Go code file, just with the main function and main package, but which also contains a lot of instructions that allow you to practice what you learned. And as always, you can then go through my solution lecture to compare your solution to mine and see how I solved this. Now, In this exercise here, I want you to start by creating a new array, very important, an array, not a slice, that contains 3 hobbies that you have, any hobbies of your choice. So create such an array with an appropriate length and value types being stored in there, and then output that array in the command line. In task number 2, you should also output print the first element and just that element, and then also the second and third element combined as a new list. So you should also output these pieces of information. In task number 3, I then want you to create a slice based on the first element of that array that contains the first and second elements. So start at that first element, but make sure you also contain the second element. Now, very important, I want you to create that slice in 2 different ways. So in the end, you should create 2 slices, though you can comment out one of the 2 approaches so that you're left with 1 new slice in the end. But create it in 2 different ways, because there are different ways of selecting the start or the first element of an array and so on. So find 2 ways of creating a slice based on that first array here that contains the first and second elements. Also output that new slice once you're done. In task number 4, I then want you to reslice that slice from task number 3 and change it such that it contains the second and last element of the original array. So don't create a slice based on the original array itself, but create a new slice on that existing slice which you got from task number 3, but change it such that it's the second and last element instead of the first and the second element which it was before. And then also print that updated slice. Now in task number 5, you should create a brand new array, but a dynamic array, and therefore it's maybe not really an array. You learned what you'll need. And that should be a dynamic array that contains your goals that you have for this course, and you should at least add 2 goals into that dynamic array right from the start. Also output that array thereafter then. In task number 6, I want you to overwrite the second goal in that array which you created in task number 5 and set it to a different goal, and also add a brand new third goal to that dynamic array. So that's what you should do in task number 6, and then output that updated dynamic array. And then I got a bonus task for you. A bonus because you'll need to do something which we haven't done before. I want you to create a product struct, that is something we did before, which has a title ID and price. And then you should use this struct to create a dynamic array, a dynamic list of such products, at least 2 products. And then I want you to add a third product to this existing list of products. Again, that is something we haven't done before, so maybe you find a way of achieving this. Otherwise, I'll show you how that works in my solution.